Now we proceed with question number 17. Question number 17 is given 0.1 molar ethanoic acid. This one is a weak acid. And 0.2 molar sodium ethanoate. This is a salt. Calculate the pH of the mixture. First, we need to identify how to calculate the pH of this mixture. What kind of this mixture? It is not only weak acid, but it's only with the presence of the salt. So in this case, we can identify that this weak acid combined with the salt will form a new solution, which is a buffer solution, because it is made up of weak acid and salt, where the salt is the conjugate of the weak acid, conjugate base of the weak acid. So, to calculate, since we can identify this solution of or a mixture form is a buffer, it is acidic buffer. So, to calculate the acidic buffer, we cannot simply use pH equal to negative log negative log concentration H plus. So, we need to use the Henderson-Hasselbalch equation, where pH is equal to pKa plus log concentration of the weak acid. Okay, what's the formula? Salt over the concentration of the weak acid. Okay, but now, initially, the concentration of the weak acid is 0.1 molar and the salt is 0.2 molar. So, when they combine to form the new concentration, they will form a mixture of acidic buffer. So, the volume has increased. So, here it's mentioned it's equal volume. Let's assume that the volume is V. Another salt also volume V, because they are new volume. So what happens if we mix together? Their volume will be 2V. But will the concentration of the weak acid and the salt would be the same in the new mixture? Of course, if we change the volume, the concentration also change. So to find the new concentration of the acid and the new concentration of the salt, we need to use M1V1 equal to M2V2. This one is for the acid. Okay, M1 is referred to the before the mixture. M2 is referred to the concentration of acid after mix with the salt. Initially, it is 0.1 molar and the volume is V times molarity after mixing, and the volume is 2V. Okay, since this one is V, it's cancelled with V. And then molarity M2 is equal to 0.1 divided by 2. It is 0.05 molar. So, in the buffer solution, our weak acid concentration is 0.05 molar, while the concentration of salt would be initially it is 0.2 molar times volume. Initial volume is V. So now, what is the concentration of the salt? This one in 2V after mixing. So V cancel with V. M2 after mixing is 0.2 divided by 2 equal to 0.1 molar. That means the salt concentration is 0.1 molar. Okay, since we already get our concentration, then we can substitute into our pH, Henderson-Hasselbalch equation. pH equal to pKa. pKa is negative log. Okay, I rewrite log concentration of the salt is CH3COONa, concentration of weak acid CH3COOH. So pKa is negative log Ka. So the value of Ka 1.8 exponent -5 plus log concentration 0.05 divided by 0.1. So final pH will be salt. Salah substitute. Concentration salt adalah 0.1 over concentration weak acid. So it is 5.05. That's all.